Hello and welcome. In this video we're going to talk about finding and citing images for use in your reports and presentations. We'll talk about how to find suitable images, as opposed of course to unsuitable ones, and then we'll talk about how to draw your own molecules and why that's superior to finding images of molecules online. And finally we're going to talk about how to reference images in your work. So first up, we'll talk about accessing the images themselves. Now I'm sure that you can all use Google Images, but the key thing here is that they must be properly referenced and they must be free from copyright. So you can see here I have used this image. I've got it from this source, so I've cited image from, and in this case because it's a web source, I've given the web address and the accession date. If you'd used a book, then you'd say image from and you'd cite the book appropriately as explained in my previous video. Okay, so let's suppose that you're writing a report on poisonous frogs. Do a quick search there, pull up the images. You can see there are a lot of images out there of poisonous frogs, but we really want ones that we can use without fear of copyright issues. So if you go into the tools menu here, you can then set the usage rights. We're not a commercial outfit, so we're not so bothered about labels for reuse by anyone. Non-commercial reuse is fine by us. We don't want to modify it. There we go. Any of these pictures now are fair game to be put in a report without fear of reprisals. So let's suppose that now we've decided this is the frog for us. We can get some more information about this by doing an image search. If you right click, copy the image address, we can now search by the image itself, and this will come up with that image, all the places that have used it, all the places with similar images. And you can see that pictures tend to do the rounds on the internet quite a bit. The same picture will show up in a lot of places. And you can use this to kickstart your research, get ideas for how to start writing your report, and then start looking for the more academic sources to actually cite. And the final thing I'm going to talk about is chemical drawing software. So this allows you to draw nice chemical structures just like this. So here's paracetamol. Everything's nicely drawn out with the 120-degree bond angles. Now there are various software packages out there. ChemDraw is the gold standard. Marvin Sketch is free, so you can download that for yourself, but we do have a site license for ChemDoodle. Now the key thing here is that you don't need to reference a structure that you've drawn. So if you go on Wikipedia, pull down a structure, that's okay, but you've got to cite Wikipedia, say image from blah 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 blah. If you draw it yourself, you don't need to, and it's much better practice to draw it yourself. Okay, so let's talk about ChemDoodle because we've got a site license for it for you all to use. If we go over here, select the bond tool, you can see there's all sorts of different bonds that we can put in. We'll go for the single bond, the obvious choice. If we click there, you put in an atom, click again and hold, you can see we can put in a bond. Choose the angle to put it at. If you just click, it'll carry on putting them in with the nice 120-degree bond angles in the linear chain. If we click on this one, it'll put one out down here. So again, we've got 120-degree bond angles all the way round. If you want a quaternary center, so a carbon with 4 substituents, click and hold. You can offset it slightly, offset that one the same amount. So you've got the largest bond angle, 120 degrees along the bottom, the two at the side equal but smaller than 120, and then the smallest angle between these two substituents here. So we can put in some stereochemistry, so let's have this bond coming up, very nice. We can change the atom using the atom tool here. Let's have an oxygen on the end. It will put it in with the required hydrogens as well. We can then put in a nitrogen here. I want to do this because I want to show you something else. So if we put 2 substituents on this nitrogen, nitrogen forms 3 bonds to make a neutral species. If you form 4 bonds, well, this shouldn't happen. We shouldn't have a hydrogen here because this makes this nitrogen pentavalent. What should happen is we can select the positive charge, put a positive charge on it. Nitrogen with 4 bonds forms a positive charge. Now, that positive charge doesn't look very pretty there. It's in the way of the bond. So what I'm going to do is I'm going to grab it. I'm going to move it so it's now above the nitrogen. I think that looks a lot prettier. In fact, though, I'm going to undo everything with the nitrogen, get rid of it entirely. We're going to talk about something else instead. We can use this to put in entire rings, so 3, 4, 5, 6, 7, 8 membered rings, various different species. let's put a 5-membered ring on here. If we click on this atom here, it will add another 5-membered ring sticking out from there. Let's have a 6 now. If we click on the entire bond, it will fuse the rings so they share a bond between them. We can go for a benzene ring, put a benzene ring on there, let's say. Okay, so now I'm going to get rid of some of this shrubbery on here. There it goes. Back to this, because this allows me to show you some other useful stuff. So if we select that molecule, we can rotate it to our heart's content. Let's put it back the way it was. We can make it bigger, smaller, whatever. The other thing that we can do is if we click up here, we can generate a simulated NMR spectrum of it. It's really nice. So it will predict where all the NMR peaks will be. It won't be 100% accurate, but they're usually pretty good. Get rid of that again. What else can we do? Well, if you decide you really want to know where all the hydrogens are, you can add the hydrogens with this button. There they are. I think this is an excellent demonstration of why we don't want to see them. Let's get rid of them. But again, it's been a bit cheeky. It's decided we want a hydrogen there. I disagree entirely. I'm going to get rid of that. We don't need it. We can select the molecule again. If you go into structure now, you can get it to tell you what the IUPAC name is, provided the molecule's simple enough. Press that, boom, it gives you the full IUPAC name for that molecule. Now this shouldn't replace your own ability to do IUPAC naming, but it's a useful tool, particularly to show that you're right when you're testing yourself. Okay, get rid of that. The other thing you might have noticed is the pass IUPAC name function. So let's poke that. And this allows you to actually put in molecules by writing them. So we're going to go for 2-methylbutane. It needs the 2 to tell it where to put the methyl group on the chain. Really, I think it's unnecessary. It should be obvious that a methyl group must go on the 2 position of butane, otherwise it would be pentane. Build the structure. Let's just get it out of the way. There it is. It's made 2-methylbutane for us. Let's grab that. Get rid of it. You can change the bond thickness, you can change the text size, all the usual things. There are other functions, so here we've got the chain tool, so we can go for a linear chain, click and hold, drag out. We can have a chain in any direction that we like, any length that we like until we run out of paper. There it is. We can go for this freeform chain tool, click and drag, round and round and round and round and round we go. So we've got a 46-membered continuous ring. It looks a little bit ugly, so if we select it, we can press this iron button, and that makes it as smooth a ring as it can possibly manage. Other tools that we've got the orbital tool, so we can draw orbitals on there. Let's have a p orbital and stick it on there. If you don't like the angle, well, you can just rotate it round and round and round. There, we want it nice and pointy up there. Just going to undo those. You can also do an entire pi bond. So there we go. Let's line it up with the bond. Pop. Doesn't that look nice? Curly arrows. So you can use single-headed arrows for radicals, double-headed arrows are our usual ones. Let's have an arrow coming off the oxygen. It's not going anywhere useful, but you get the idea. You can draw arrows. You can select those arrows. You can make them curlier, less curly by pulling this one. You can change where they're going to by spinning that around. So I really would recommend having a go on ChemDoodle, have a play around, see what it can do for you. You may find that it takes a little bit longer in some cases to draw your structures using this, but I'm sure you'll agree they look a lot nicer than they would if you were hand drawing them, unless you have astonishingly good drawing and writing skills. Okay, so in this video we've considered the 2 different aspects of the use of images in your work. The first, that they should be free from copyright, and the second, that they should be appropriately referenced. So we've got 2 different standards here. The first, an academic standard, they must be appropriately referenced, and the second, a separate legal standard that even if they are appropriately referenced, they must also be free from copyright to avoid potential problems. Of course, you can get around both of these issues by just making an image yourself. So if you draw a molecular structure yourself using ChemDoodle, or if you make your own image to appropriately illustrate a point, then you don't need to worry about copyright because you made it, it belongs to you, and you also don't need to worry about referencing because you made it, it belongs to you.